We're going to talk about brittle deformation next. As we talked about before, there are three predominant types of stresses. If there's extensional stress, stretching, then the brittle behavior forms normal faults. If there's compressional stresses, shortening, then we call those reverse or thrust faults. And if there's a shearing stress, then there's no change in length. We're not shortening or lengthening anything, but we're producing a fault we call a strike-slip fault. And we'll start there. Why strike-slip? Well, shearing faults tend to be vertical, and therefore the slip direction, the direction the fault is moving, is parallel to the strike. So we call them strike-slip faults. This is the San Andreas Fault. It's one of the most famous strike-slip faults in the world, and it's so big you can see it from an airplane. Now this one has arrows on it showing you the direction of movement, and you can pick that out yourself by looking at this displaced stream bed, which has been moved so that the part that's away from you has moved to your right. But let's imagine you're standing over there on the other side of the fault from your current view and you're looking back towards me, then the river would look as if it had been displaced to the right. So that's the interesting thing about strike-slip faults. You can define their direction of movement by what's happening on the opposite side of the fault to what you're standing on. If the opposite side of the fault is moving to the right, we call it a right lateral strike-slip fault. And if the opposite side is moving to the left, then we call it a left lateral fault. And it doesn't matter which side you're standing on to tell that. So the San Andreas is a right lateral strike-slip fault. Now, a normal fault happens when there is stretching involved. So let's take a look at this block diagram first and have a couple of other terminology words thrown out there. We define the fault plane as the surface where the sliding happens, and what is underneath the fault plane, if it's tipped, is called the footwall, and what's above it is called the hanging wall. So the fault plane is tipped at an angle, and the stuff on top of it is the hanging wall block. The stuff underneath it is the footwall block. If the hanging wall moves down with respect to the footwall, that happens when there is stretching, and that we call a normal fault. And here's a picture of a normal fault in the field where you can see pretty clearly that marked with a white arrow there that the hanging wall has moved down in this particular outcrop. Now the opposite of a normal fault is a reverse fault, and that happens when you squeeze something together. You need to shorten the area, make less room, and therefore the hanging wall moves up with respect to the footwall. And in this picture on the left, which one's the hanging wall? Well, it's A, right? A is on top of the fault plane, which is marked in blue, and the hanging wall is moved up with respect to the footwall, as you can see by the marked yellow layer, orange layer. And so that is a reverse fault. Now sometimes reverse faults are called thrust faults, and the main difference really is semantics. Generally, geologists talk about thrust faults when the angle of the fault plane is quite low. So it's a reverse fault either way. The hanging wall is moving up, but if it's a very low angle fault, it's commonly called a thrust fault. So here you go, 4 types of faults. Which is which? A, hanging wall moving down, extension, that's a normal fault. B, hanging wall moving up, compression, that's a reverse fault. C, hanging wall also moving up, but at a very low angle, we'd call that a thrust fault. But if you said reverse fault, that's okay. And D, the direction of slip is the same as the strike line, and so D is a strike-slip fault.